or else they'll think the class is out of control. All right, Sir Kixer, say it. Ticks. Okay. So that's an action again. This is an embarrassingly easy lesson today. Actually, there's nothing new. Student dying in the back there. Nothing new. Except maybe with the last thing that I cover. And a couple tough questions at the end of your homework that you'll do your best on. All right, and then I'm just going to go to this real Mickey Mouse geometry 2 years ago question to actually write down a concept, that probably the first thing that you write down, because I doubt you'd write this one, unless you want to use this as a bridge. I must have snagged myself. Didn't even see that. It's almost a big tragedy. No, don't do it, Mr. S. All right, sorry. I don't know where to put this. Sorry, this shouldn't be on the tape. I know I'm not. What the? Okay, I'm okay now. All right. So remember, it's a perspective of what angle you're looking at. So sine of A, who's opposite A? What side measure? Oh, crap. 7, okay. Who's the opposite? Who's the adjacent side? When you're looking at angle A, 24, and then the hypotenuse is always 25. So what's the sine of A? Mickey Mouse, 7 over 25, right? Who's the cosine of A? Adjacent over a hypotenuse, 24 over 25. Mickey Mouse. Tangent of A, 7 over 24, right? Hopefully I'm not making any mistakes. But then when you change it to B, what's the side opposite B? Now it's 24. All right? So sine of B is 24 over 25. Cosine is 7 over 25. Tangent is 24 over 7. Now I'm going to show you the rule that probably the first thing you should write down and you're going to have memorized. Hey, how come angle A and angle B are complementary? Well, in the illegal notes, when the teacher just answers his own questions and lets the students sit there, it's because a triangle's angles add up to what? Come on, class. And one of the angles is 90, so what's left over for the other two? So A and B are complementary. So notice the sine of A is equal to the, who does the sine of A equal to? Cosine of B. And the sine of B is equal to the cosine of A. So this is a true rule. And then I'll go back and show you the other trig functions, at least tan and cotan, and then you can assume what's true in the middle is true. That's what the cofunction identities are. Cofunction starts with what two letters? Co, C-N-O. And complementary starts with what two letters? C-O. What I'm giving you is an illegal trick, because I'm not supposed to do that either. You can turn me in on this video. The illegal teacher that I am. An illegal trick to remember that this is the cofunction identities. Oh, brother, I forgot about that. I don't know why they call it that. I don't know. Really don't know. It's just the name. I'm just the informant on this one. Sorry for not being better there. Now, I'll show that again if you didn't have time to write. Let's go back up to that one and then do, like, what's cotan of A? Let's put that in blue. What's cotan? What in the? What's cotan of A? 24 over 7. Which happens to equal the tan of B. So tan of an angle equals cotan of its complement. Then I could do the same thing with cotan of B, which is 7 over 24, which is equal to the tan of A. And those angles are complements of each other. So that's what that says. We can do the same thing with secant and cosecant, but let's move on. Another thing, I do like this development, although it is something you should already know. The development of a 30, 60, 90 right triangle and why the sides are what they are and what you have to have memorized. So what they do is they start off with, this is their book. This is why I love the book. You can actually read it, and it's an easy read, and you can understand where things come from pretty well. So you start with an equilateral triangle, then you draw an, anyone know what that's called? Altitude, isn't that what it's called? Everyone's looking at me like I'm a freak, which may be true, but not because of what I just said there. All right, and then what does an altitude do to the opposite side in a isosceles or equilateral triangle? Okay, it bisects. And by the way, this is equiangular, so it's equilateral. And they just made a choice to make all the sides 2. It was a choice. Then they dropped the altitude, and then this is bisected, so this is 1 here. So how do I find x? Through the glory and power of the Pythagorean theorem. And then 2 squared is 4, minus 1 is 3. And then you get root 3. So 1 is the side opposite 30. By the way, why is 2 bigger than root 3? Don't just say because. 2 is the square root of what? 2 is the square root of what? This always drives me nuts, the students that know 1, root 3, and 2 are the sides of a 30, 60, 90, but then they put the sides in the wrong spot. Makes me angry. Where do they belong? Because the smallest side is opposite the smallest angle. The largest side is opposite the. These are not mistakes we should be making in honors. And the side in the middle is I don't know how to even say that one. Just get the largest with the largest, smallest with the smallest, and then root 3 goes opposite. You okay? Did I say good morning? You're mad, aren't you? Good morning. All right. Now, would it matter if I put 4, 4, 4? No, because then this would be 4, 4. This would be 2. But then what would this become? 2 root 3. And then that's the whole idea of also knowing the multiples. Okay, any multiple of this 1, root 3, 2 situation is true for a 30, 60, 90 because they're all similar. How's that come? Similar. Isn't that annoying? Okay, and then do tan. We did this last year. This is why you should be embarrassed about these notes. But I just felt like I wanted to cover it just to refresh your memory because it's okay. What's the sine of 30, everyone? Or no one, the way things are going right now. Because let's be honest, you're not saying a thing. 1/2. Oh, all right, what's the cosine of 30? Root 3 over 2. What's the tan of 30? Yeah, let's get to that rationalization right off the bat. And then you know what? Your calculus teachers next year, you should have them close that Chromebook. Thank you. Your calculus teachers next year, if you walk in there not knowing these after what we do in this book, oh, they're going to be furious. They're mean, too. What's the cosecant of 30? Mean. 2. That you think being in the weeds is bad. They set the weeds on fire and put spikes in it and then say, get out in the weeds. That's what they do, so you better be ready. What's the secant of 30? 2 root 3 over 3. And then what's the cotant of 30? Root 3. And then we're going to do this again. Well, it's all about perspective. What's the sine of 60? We'll do these offline. I'm bored to whatever kind of sort of memorized. Hey, the sine of 30 is equal to the cosine of 60. What's 30 and 60's relationship? They are complementary. The cosecant of 30 is equal to the secant of 60. So there's that other complementary relationship now that we can, prove it or at least look at it. That's what that cofunction identity is saying. And we could look at some of the other ones. All right, and then this one. This is easy. 45, 45, 90 is an isosceles triangle. I couldn't care less. And it's couldn't care less what side measure you use. 1's easy. So 1, 1, square root of 2. But why? Because of the Pythagorean theorem. And then you root it. 1 squared plus 1 squared is 2. Square root of 2. If I put a 4 here, this would be 4, 4, 4 root 2 through the Pythagorean theorem as well. Be the same thing. That'd be 32, by the way. What's the square root of 32? 32 is 16 times 2. What's the square root of 16? 4 root 2 stuck in jail. Just like you might feel in this classroom. All right. So what is, and it doesn't matter what ratios you do. Sine of 45, I don't care which one you pick. 4 over 4 root 2 is the same as 1 over 1 root 2. What is 1 over 1 root 2? Root 2 over 2. And I'll go offline on this and just show these answers after. And then if I'm going too fast, I'll go back to this. You're not filling it. This chart's already been filled out. I already did it. You should really memorize this. And actually, not yet. But just give yourself a chance as you go through these questions over and over and over again. Same thing we did last year. That eventually, just by osmosis, if I'm using that word correctly, it should just invade your brain. And then you should, right off the bat, like have a nightmare. Sine of 30 is a half. Ugh. Okay? Because that's how much you're going to be doing this stuff. All right? All right. Sorry. So if you didn't have time to write that down. Okay. So these stupid little questions just to prove you know what you're doing. Write each function in terms of it. See, this is a vocab word. What does this mean? You come out to my desk and I say, sit down. That's your test. You're supposed to know that word. Ah, that's your nightmare. Okay, so what's cosine of 52 equal to? Sine of 38, Mickey Mouse. What's tan of 71 equal to? I can't even see numbers. Cotan of 19. What's secant? Oh, come on. Cosecant of what? Yeah, this one was tough to think about that number. And then do you remember the question that I threw on the test? No, it wasn't on the test. I don't think it made it. Remember in the end of a homework assignment? One of them, I think 1-3, we gave this silly question. Remember this? What is 1 over cosecant the same as? Sine. So what you were expected to do was do this. I put an extra set of notes in the calendar for those that accessed it. It was the day I was gone when I was being culturally and refined and became a better person. I actually did. What do you do on this? Sine of this equals sine of that. Well, that's the same as horse. I don't know how to draw her. It looks like a flag. Times x equals horse times, I could draw a skunk. What's x equal? That's skunk. It's not math. It's just matching. So sine of this equals sine of that only if this equals that. So what I'm demonstrating is that's one way you could attack these suckers. Cosine of this equals sine of that. Interesting. And it just says find the solution, but the directions kind of give it away. There's two ways of doing it. One's a little bit easier than the other, but this is the way I've always showed the students. I wanted them to use the cofunction. So what I wanted to do was get it into the horse times dead skunk equals, I forgot, horse times x, and then x equals dead skunk. So what you want to do is get this to be cosine equals cosine. So how does that work? What do I have to do? Cosine of what? Yeah, go ahead. 90 minus the quantity of 3 theta minus 2. Then I can drop the cosines. And I'm not going to solve this for you. It's grade school stuff at this point. Or, go ahead and find theta. Or, if cosine of this angle equals sine of that angle, what do you know about these two angles? They're what? They're complementary. So you could be more direct by just saying, okay, since that's the case, then this is true. And both answers will lead to the same, or both equations will lead to the same answer because they're both, whatever, the regulars. This next part. Sorry, a little bit crazy on this, and good thing this is on the video. I'm not ready yet. Okay, boom. Okay, what happens to x and y as theta increases? And by the way, we're going to keep r fixed. When I did give this out last year, the unit circle. Do you remember that? And I showed it, and I had a nice colorful version, but I never let you use it. Do you remember that? Never. I told you it was a crutch. All right, you got to get away from it. But why is it called a unit circle? What is r equal to? What is the radius of that circle equal to if it's called a unit circle? 1. So what I'm doing is I'm fixing r to be a value. So if r doesn't change, but we change theta, as theta increases, what happens to the y value? What happens to the y coordinate? Increases. If I keep r the same, and as theta increases, y increases, what happens to x? Look at what happens to x. It decreases as. So, as theta increases, now we're going to get crazy. What? Oh, no. Sine of theta, what? Now stop. What is sine of theta? Sine of theta is y over r. So what happens if r is fixed at 1, but as theta increases, what does y do? What does y do? Increases. So what does sine of theta do? Increases. The evaluation of whatever sine of theta is y over r. And since y is increasing, but r is fixed, then sine of theta increases. So as theta increases, what does cosine of theta do? Decreases. Because x gets smaller as theta increases. Now this is crazy. You know how to take notes, right? Dash, dash, dash. That means as theta increases again. Note-taking skills. Cross-curricular. What does tan of theta do? What does tan of theta do? Now why? Okay, what is small over big when theta is small? What's small over big? Small. And then let's look at when theta is real big. What's big over small? Big. So what does tan theta do? It increases. Now what do you think secant does? Secant's the reciprocal of cosine. So when I flip decrease, what does that actually do? Increase. When I flip increase for cosecant, what does cosecant do? Decrease, because cosecant's r over y. As theta increases, y gets real big. That's 1 over real big, which is small. And what are we doing these silly little questions for? Look at 37 through 44. What's the answer to number 37, which is actually one of your homework assignments? No calculator. Is it true or false, number 37? True. Why is it true? As theta gets bigger, sine of theta is what? Bigger. And that's how you answer all these questions without a calculator. Isn't that crazy? And then this one, you have to know the relationship. What does tan do as tan increases? What does tan do as tan increases? What does it do? By the way, I didn't tell this the second hour. Notice the angle measure that they have here. What do you think this is? True or false? See, I don't really know because these angles are the same. So what do you think the key angle is where this there's a state of equilibrium, let's say? What angle measures right in the middle as we increase? 45. So this angle is on the smaller or bigger side of the increasing x and y values. Smaller. Okay, so is this true or false? So as theta increases, tan increases. As theta increases, cotan decreases. So is this true or false? This is actually true, because tan gets bigger once it's past 45 than cotan. Because tan's smaller than cotan from 1 up to 45. And then after 45, it gets bigger than cotan. So that's how you do it without a calculator. Did you all get that? All